So if I want to factor a trinomial that has a leading coefficient other than 1, like this one here, where I've got a 3 as leading coefficient, then I'm going to start kind of like I would before when there was no leading coefficient, by creating my x. Now instead of putting the last term of the trinomial in the top, I'm going to multiply the first and last term together. So 3 times 8 would give me 24. So I put 24 up there, and then the middle term goes on the bottom just as before. And I'm going to fill out this triangle just like I did previously. I'm looking for two numbers that multiply to give me 24, but add up to give me 14. And so if I go through the list here, looks like 12 and 2 are going to fit the bill. And so now what I do with these numbers is going to be the different thing. Before, I would plug them in to a polynomial where I have x's as the leading terms, and then I'd fill in, say, the plus 12 and the plus 2 there. But here, that's just not going to work. Obviously, if I were to distribute this back out, I'm never going to get that 3x squared term up front. So instead of doing that with those numbers, I'm going to use those two numbers to split up the middle term of my polynomial. So the first term stays the same. And now instead of a 14x in the middle, I'm going to have plus 12x plus 2x. And then the plus 8 is still there at the end. So if I simplify this, well, these two terms still add up to 14x. So I haven't really changed anything. It just looks different. Now I have a 4-term polynomial that I can factor by grouping. So I'm going to just split this up and look at the two halves separately and factor each half. So just from the first half, the 3x squared plus 12x, I can factor out a 3 from the 3 and the 12, and they both have at least one x in there, so 3x can be factored out. And so if I factor that out, left is going to be just an x term from 3x squared, and from the 12x, I'll have just 4 left over. And I'm going to do the same thing on the other side. So over here, I can factor out the GCF of 2, and then left over would be x plus 4. Now if you'll notice, I'm now down to 2 terms. They're really big, ugly terms, but there's 2 of them. And both of those terms have an x plus 4 in them. So that's their common factor. And so I can factor that out just like I have previously with factoring by grouping. So I can factor out x plus 4. And left over from the first term, if I pull out the x plus 4, then just the 3x is going to be left over from that one. And from the second term, if I pull out x plus 4, just the 2 is left over. And now I have the polynomial factored.